Welcome back, everyone, to the deep dive. This time, we're going to be doing a deep dive into the world of quantum computing.
Exciting stuff.
It really is. And, it's a little intimidating, to be honest.
Yeah, a little bit, yeah.
It feels very much like the next big thing, like when the internet was first becoming a thing and
Yeah.
nobody really knew where it was going, but it was exciting and scary all at the same time. And this kind of feels the same way.
It's like that feeling of being on the cusp of something huge.
Exactly.
You can sense the potential, but it's so vast, it's almost overwhelming.
Yeah, and we've got a ton of research articles, news stories, all this stuff that people have sent in.
A whole stack of them.
Yeah, a whole stack. So we're going to be going through it all and pulling out the most interesting bits.
Trying to connect the dots and
Yeah,
see where this whole quantum thing is headed.
absolutely. So let's just jump right in.
Good.
So first of all, what is a quantum computer? I think most people have sort of heard the term, but they don't really know what it is.
Yeah, it's one of those things that gets thrown around a lot, but the actual mechanics of it can be a little mind-bending.
Yeah, so how is it different from the computer I'm using right now?
Okay, so think about it this way. Your computer uses bits, which are like tiny switches that can be either on or off, representing a 1 or a 0. A quantum computer uses qubits, and those are also like switches, but with a quantum twist.
Okay, quantum twist. There's that word again, quantum
Yeah, I know it sounds a little sci-fi, but it's real. And it all comes down to this concept called superposition.
All right, break that down for me. Superposition.
Okay, so in superposition, a qubit can be both 0 and 1 at the same time. It's like spinning a coin and having it land on both heads and tails simultaneously.
Okay, I officially don't understand.
Okay, it's a tough concept to wrap your head around.
Yeah.
Even physicists have been debating this stuff for a century.
Okay, but how does that make it more powerful? How does being in two states at once actually help you do calculations?
Okay, let's try this. Imagine you're trying to find something in a giant library. A regular computer would have to look at every book one by one, right?
Right, page by page even.
Exactly. But a quantum computer, using superposition, could look at every book, every page, all at the same time.
Oh, wow.
That's the power of parallel processing. It's like having a million Google searches happening at once.
So it's basically like speed on steroids.
Pretty much. It can solve certain problems exponentially faster than any classical computer.
And that's why there's all this talk about, quantum computers breaking encryption and all this scary stuff.
Yeah, that's one of the big implications, but it's not just about breaking things, it's also about building things.
Okay, so what kind of things are we talking about building here? What are the real world applications?
Well, you mentioned drug discovery. Quantum computers could revolutionize that field by simulating how molecules interact, allowing us to design new drugs and therapies much faster than we can today.
That's incredible. Instead of spending years and years in a lab, we could basically just design the perfect drug on a computer.
That's the idea. And goes beyond medicine. We're talking about designing new materials, creating unbreakable encryption, developing financial algorithms that could reshape the global economy.
Okay, so we're talking about a potential revolution here across pretty much every industry.
Yeah, it's a big deal.
And that's why you've got this whole quantum arms race going on, right? Countries are pouring billions of dollars into research.
Exactly. It's like the space race of the 21st century. Everyone wants to be the first to unlock the full potential of this technology.
And there's a lot at stake, right? National security, economic dominance.
Absolutely. Whoever controls quantum computing will have a significant advantage on the world stage.
Okay, so let's talk about that race then. Who are the major players here?
Well, the U.S. and China are the two big ones. They're both investing heavily in quantum research and development.
Yeah, and one of the articles you sent talked about how China is actually outspending the U.S. by a pretty significant margin.
That's right. They've committed something like $15 billion to quantum research, which is 3 times more than any other country.
Wow, that's a serious commitment.
It is. They're not messing around. They see quantum technology as key to their future economic and military dominance.
Okay, but money isn't everything, right? You need the talent, the infrastructure, the right kind of environment for innovation.
True, but China is definitely making strides on all those fronts. They've built world-class research facilities, they're attracting top talent, and they're filing patents at an astonishing rate.
So they're not just throwing money at the problem, they're actually making progress.
Oh yeah, they're making serious progress. They're already ahead of the game in areas like quantum communications, for example.
Okay, so what about the U.S.? What are they doing to keep up?
Well, they're definitely aware of the challenge. One of the big things they've done recently is pass the CHIPS and Science Act, which is designed to boost domestic research and development in key areas like quantum computing. Exactly, and it's not just about government funding either. Private companies like Google, IBM, Microsoft They're all investing heavily in quantum research as well.
So it's like a whole ecosystem, right? Like a combination of government support, private investment, and academic research.
Yeah, exactly. It's a complex landscape, but the bottom line is that the U.S. is taking the quantum threat very seriously.
And it's not just a two-horse race, is it? Like there are other countries involved too.
You're right, there are other players in the game. You sent me an article about what Singapore is doing with nanosatellites, remember?
Yeah, that's right. Nanosatellites for quantum communications. That's pretty cool.
Yeah, it's an interesting approach. They're focusing on building a commercially viable network that's accessible to a wider range of users.
So it's like a different kind of race then. It's not just about national prestige, it's also about who can make this technology work in the real world.
Exactly, and that's ultimately what matters, right? How can we use this technology to solve real-world problems and make a positive impact?
Absolutely. So we've got this intense competition, this sense of urgency, and a technology that's still very much in development.
It's a fascinating time to be alive.
It really is. And I'm a little bit nervous, to be honest.
I understand. I think we all are, but it's also exciting, you know? It's like
Sure.
we're standing on the threshold of a new era.
Yeah, an era where the rules of the game are being rewritten and the possibilities seem almost limitless.
And the only way to navigate this new era is to understand it, to learn about it, to dive deep into the quantum world.
Well, then let's dive in, shall we?
Let's do it.
All right, so we've talked about the race, we've talked about the potential, but let's get back to the basics here. What does a quantum computer actually look like?
Ah, good question. You know, in movies, they always show these giant machines with flashing lights and whirring gears.
Yeah, like something out of Star Trek.
Exactly. But in reality, quantum computers are surprisingly small, especially the core component, the chip where the qubits reside.
Okay, so you sent me an article about IBM's Heron chip, which has something like 133 qubits on it.
Yeah, that's a cutting-edge chip. It's about the size of a quarter, I think.
A quarter, wow, that's tiny.
It is, and it's incredibly valuable.
Yeah,
Yeah, we're talking millions of dollars just for that one little chip.
and all that power packed into something so small.
It's mind-blowing, isn't it? It's like holding the future in your hand.
Yeah, but why so small? Is it just about efficiency or is there something else going on?
Well, miniaturization is definitely part of it, but it's also about the delicate nature of quantum states.
Delicate in what way?
Well, qubits are incredibly sensitive to their environment. Any kind of interference can disrupt their quantum properties.
Okay, so like what kind of interference are we talking about?
Heat is the big one.
Hmm.
Even the tiniest bit of heat can cause errors in the calculations. So these chips have to be kept incredibly cold.
Like how cold?
We're talking fractions of a degree above absolute zero, colder than the vacuum of space.
So they're creating like the coldest place in the universe right here on Earth?
Pretty much. It's a remarkable feat of engineering when you think about it.
It is. I mean, it's kind of poetic in a way. This tiny chip containing the building blocks of a whole new technology kept at a temperature that's almost unimaginable.
Yeah, it really speaks to the ingenuity and the ambition of the scientists and engineers working in this field.
Okay, so we've got these powerful chips. They're super cold. They can potentially do all these amazing things, but there's also a dark side to this technology, right?
Yeah.
Like we've mentioned, the threat to encryption.
Right. That's one of the biggest concerns, and it's something we need to be prepared for.
Yeah, because right now, pretty much everything we do online relies on encryption, right?
Exactly. Your bank transactions, your emails, your online shopping, all of it is protected by encryption algorithms.
And these algorithms, they rely on the fact that it takes a really, really long time for a normal computer to factor large numbers, right?
Exactly. It's a computationally intensive task that would take classical computers millions, if not billions of years to crack.
But a quantum computer could potentially do it in a matter of minutes.
That's the fear. And it's not just a theoretical possibility. It's something that security experts are actively working to mitigate.
Okay, so what are we doing to protect ourselves? Like, is there any way to stay ahead of the quantum threat?
Well, one promising avenue is quantum-resistant cryptography. Essentially, it's about developing new encryption algorithms that are resistant to attacks from both classical and quantum computers.
Okay, so it's like building a fortress that can withstand any kind of siege.
Exactly. And this is an area where there's a lot of research and development happening right now. Governments, companies, academics are all working on this problem.
And the stakes are pretty high, right?
Absolutely. If we don't develop robust quantum-resistant cryptography, the consequences could be catastrophic.
Okay, so let's say we figure out the encryption problem. We build these quantum-proof fortresses. What happens then? Like, what's the best case scenario for this technology?
Well, the best case scenario is that we use this technology to solve some of the world's most pressing problems.
Like, what kind of problems?
Well, we've already talked about drug discovery and material science. But there's so much more. We could revolutionize energy production, develop personalized medicine, create more efficient transportation systems. The possibilities are almost endless.
So it's not just about making our lives easier, making more money. It's about actually making the world a better place.
It's about using this incredible power for good to solve problems that have plagued humanity for centuries.
Wow, that's a pretty inspiring vision.
It is, and it's something worth striving for.
It's
what motivates a lot of the researchers and scientists working in this field.
Yeah, it's like they're not just building a technology, they're building a better future.
Exactly, and that's what makes this whole quantum journey so exciting. It's not just about the science, it's about the human potential.
It's about using our ingenuity and our creativity to create a world that's healthier, wealthier, and more sustainable.
Absolutely, and that's a future worth fighting for.
All right, so we've got this powerful technology, we've got the potential for good, we've got the potential for disruption. It's a lot to take in.
It is, but it's also incredibly fascinating.
It really is, and I think we've only just scratched the surface here.
There's so much more to explore, so many more questions to ask.
Well, then let's keep exploring, shall we?
Let's do it. So much more we could do, right? Like we've been focusing on like the big players, the US and China, the race for dominance and all that. But there's this whole other side to quantum computing, the potential to like change our everyday lives in ways we can barely imagine.
Yeah, exactly. Like we talked about drug discovery, which is obviously huge.
Huge, yeah.
But what about other fields like materials science? You sent me an article about that.
Oh, yeah. That's a fascinating area with huge potential. Imagine being able to design materials at the atomic level.
Like, what kind of materials are we talking about?
Anything you can think of. Lighter, stronger materials for airplanes and cars, super efficient solar panels, even self-healing materials that can repair themselves.
Self-healing materials? That's wild.
It is. And it's all thanks to the ability of quantum computers to simulate the behavior of matter at an incredibly detailed level.
Okay, so how does that work? Like, how do you design a material on a computer?
Well, right now, designing new materials is often a process of trial and error. You mix things together, test them out, and see what happens.
Kind of like cooking without a recipe.
Exactly. But with quantum computers, it's more like having a molecular blueprint. You can see how atoms and molecules interact with each other, how they bond, how they respond to different conditions.
So you can basically predict how a material will behave before you even create it?
Precisely, it takes a lot of the guesswork out of the process.
That's amazing. It's like having a virtual laboratory where you can play with the building blocks of the universe.
It is, and it's not just limited to material science. This kind of simulation power can be applied to all sorts of fields.
Okay, so like what else? What other everyday applications are we talking about?
Well, you mentioned financial modeling earlier, remember?
Right.
That's another area where quantum computers could have a huge impact.
Because the financial markets are so complex, right? Like it's impossible to predict everything that's going to happen.
Exactly. There are just too many variables. But quantum computers could help us make better predictions by analyzing vast amounts of data and identifying patterns that humans might miss.
So they could help us avoid another financial crisis.
Potentially, yeah. Of course, no technology is perfect. But quantum computers could give us much better tools to understand and manage risk.
Okay, so we've got materials, science, we've got financial modeling. What else?
Well, one area that's really exciting is personalized medicine.
Personalized medicine. How does that tie into quantum computing?
Well, imagine being able to tailor medical treatments to an individual's unique genetic makeup.
So instead of like a one-size-fits-all approach, you get a treatment that's specifically designed for you.
That's the idea. And quantum computers could play a key role in this by helping us understand how genes interact with each other and how they respond to different drugs.
So it's like taking precision medicine to a whole new level.
Exactly. And it could revolutionize healthcare as we know it.
Wow. It sounds like there's almost no limit to what we can do with this technology.
It's pretty mind-blowing, isn't it? But it's important to remember that there are also potential downsides.
Right. Like what we've talked about, the encryption problem.
Yeah, that's a big one. But there are other concerns too, like what happens to jobs when machines become smarter than humans?
Yeah, that's something I've been thinking about a lot. Like, if quantum computers can do all these amazing things, what does that mean for the future of work?
It's a valid concern, and it's something we need to be thinking about now, not just in terms of job displacement, but also in terms of education and training.
So, like, what kind of skills will people need to thrive in a quantum-powered world?
Well, obviously, STEM skills are going to be crucial. But it's not just about technical skills. It's also about creativity, critical thinking, problem solving, the ability to adapt to a rapidly changing world.
So it's not just about teaching people how to code, it's about teaching them how to think.
Exactly. And that's a challenge for our education system. We need to move away from rote memorization and standardized testing and focus on developing the skills that will be essential in the 21st century.
It's a pretty daunting task.
It is, but it's also an exciting one about preparing the next generation for a future that's full of possibilities.
Yeah, and it's not just about education either, right? Like, we need to make sure that the benefits of this technology are shared widely.
Absolutely. We can't allow a quantum divide to emerge where only the wealthy and powerful have access to these tools.
Right. It needs to be a technology that benefits all of humanity, not just a select few.
Exactly. And that's going to require a lot of thought and effort from governments, businesses, and individuals alike.
Okay, so we've talked about the potential benefits, the potential risks, the need for education and equity. What else do we need to consider as we move into this quantum future?
One thing that's often overlooked is the ethical dimension of this technology.
Ethics. Like, what do you mean?
Well, quantum computers give us the ability to manipulate matter and information at an unprecedented level.
Yeah.
And with that power comes a responsibility to use it wisely.
So it's not just about what we can do, it's about what we should do.
Exactly. We need to think carefully about the potential consequences of our actions and make sure that we're using this technology for good.
Okay, so what are some specific ethical concerns that we need to be aware of?
One big one is privacy. As we've discussed, quantum computers could potentially break current encryption methods, which means that all our personal data could be at risk.
Right. That's a scary thought.
It is, and it's not just about individual privacy. There are also national security implications.
Yeah.
Imagine a hostile nation state using quantum computers to steal government secrets or disrupt critical infrastructure.
That's like something out of a spy movie.
I know, but it's a real possibility, and it's something we need to be prepared for.
So how do we protect ourselves? Like, what can we do to mitigate these risks?
Well, one important step is to develop strong regulations around the use of quantum technology.
Regulations? Like, what kind of regulations?
Well, for example, we might need laws that restrict the use of quantum computers for malicious purposes, or laws that require companies to take steps to protect user data.
So it's about striking a balance between innovation and responsibility.
Exactly. We want to encourage progress, but we also need to make sure that this technology is used ethically and safely.
Yeah, because ultimately this technology is a tool. And like any tool, it can be used for good or for evil.
Precisely. It's up to us to decide how we want to use it.
And those decisions have the potential to shape the future of humanity.
No pressure, right?
No pressure at all. But seriously, this is some heavy stuff, and I think it's important that we have these conversations now before it's too late.
I agree. We need to be proactive, not reactive. We need to anticipate the challenges and opportunities that lie ahead and work together to create a quantum future that benefits everyone.
Well said. And I think that's a perfect segue into our next topic, the potential for quantum computing to revolutionize our understanding of the universe itself.
Ah, yes, the cosmic connection. You sent me some fascinating articles about that.
I did. Like, I find this stuff absolutely mind-blowing, the idea that we could use quantum computers to simulate the creation of the universe or to unlock the secrets of dark matter.
It's pretty wild, isn't it? And it really highlights the fact that quantum computing is not just about technology. It's about expanding our understanding of the fundamental nature of reality.
Yeah, it's like we're taking a giant leap forward in our quest to understand the universe and our place within it.
Exactly. And who knows what amazing discoveries await us on this journey.
It's a lot to absorb, isn't it? I feel like we've covered so much ground.
We have from like the nitty-gritty science to like the geopolitical stuff, our ethical questions. It's a huge topic.
It really is, and it feels like we've only just scratched the surface.
Yeah, we have. This field is moving so fast. Who knows what's going to happen in the next 5 or 10 years?
It's like we're looking at a map of uncharted territory. You know, we can see the outlines, but the details are still blurry.
But even though we can't predict the future with certainty,
Mm-hmm.
we can prepare for it, right? We can equip ourselves with the knowledge and the tools to navigate this new landscape.
Exactly. And I think a big part of that is fostering a sense of curiosity and wonder. You know, we need to inspire the next generation of quantum explorers.
Absolutely. We need more scientists, more engineers, more people who are passionate about pushing the boundaries of what's possible.
Because that's how progress happens, right? Through trial and error, through taking risks, through embracing the unknown.
Exactly.
Uh,
And that's something we can all do regardless of our background or expertise. We can all be part of this quantum journey.
It's about nurturing that human spirit of inquiry, that drive to understand the universe and our place within it.
And that spirit is what will ultimately guide us as we navigate the complexities and the opportunities of this quantum era.
Because a future isn't something that's preordained, it's something we create together.
Well said. It's a tapestry woven from scientific discoveries, technological innovations, ethical considerations, societal choices, and individual actions. We all have a role to play in shaping that tapestry.
So as we wrap up this deep dive, I want to leave our listeners with a final thought. Don't be intimidated by the complexity of quantum computing.
Yeah, it's easy to get overwhelmed, but remember, it all starts with curiosity.
Embrace the mystery. Nurture your curiosity, and remember that the most important questions are often the ones we don't yet know how to answer.
And who knows? Maybe someday you'll be the one making those groundbreaking discoveries, pushing the boundaries of knowledge and shaping the quantum future for generations to come.
That's a great note to end on. So to all our listeners out there, keep exploring, keep questioning, and keep wondering. The quantum world is waiting to be discovered.
It's a vast and fascinating world, and we're only just beginning to understand its potential.
Well, that's it for this episode of The Deep Dive. We hope you enjoyed our exploration of the quantum world.
It's been a pleasure diving deep with you.
And to all our listeners out there, thanks for joining us. And until next time, stay curious.